So today in class and yesterday in class we talked about dividing using repeated subtraction and divide using partial products. Let's take a look at repeated subtraction first. Okay, here's a problem. 7, how many times does 7 go into 35, or 35 divided by 7? We're going to use repeated subtraction to solve this problem. Now what repeated subtraction says is that I can take my divisor and subtract it from my dividend over and over and over and over and over again, and eventually I'm going to get my quotient. So I'm going to start by taking 7 and subtracting that from 35. And I did that one time, so I'm going to put my 1 over there. 35 minus 7 is 28. I'm then going to go again and subtract 7. That's the second time I've done it, and that's 21. I'm again going to subtract 7. That's the third time I've used that 7, and I'm left with 14. Again, I'm going to subtract 7. That's the fourth time, and I'm left with 7. And finally, fifth time I'm going to subtract 7, and I'm left with 0. With repeated subtraction, you stop as soon as your answer down here is either 0 or less than your divisor. If it's less than your divisor, then you have a remainder. If it's 0, then you don't have a remainder. Now, in order for us to figure out what our quotient is, we're going to figure out how many times we subtracted 7. So we subtracted 7 1 time, 2 times, 3 times, 4 times, 5 times. So 35 divided by 7 is equal to 5. Now, this was a really easy problem that most of you know how to do without repeated subtraction, but if you forgot what 35 divided by 7 was, you could always use this strategy to solve this problem. So that's what repeated subtraction means. You're taking this divisor and you're subtracting it over and over and over and over and over again from your dividend. Let's take a look at what using partial quotients looks like. Okay, we have a little bit bigger of a problem here that we're going to use partial quotients to solve. Again, we're going to draw this line over here, and this line is going to help us keep everything in order. Now, when we're using partial quotients, we can solve these problems different ways and still get the correct quotient. What I want you to think about when you're using partial quotients is using facts that you know to solve these problems. So, one fact that I know about 5, and I know this fact really, really well, is that I can take 5 and multiply it times 10, and I'm going to get 50. Now, this number down here that I'm putting is going to be a product of my divisor and the number I'm putting over here. So 5 times 10 is equal to 50. Now again, just like with repeated subtraction, I'm going to subtract. 5 minus 0 is 5. I can't take 3 away from 5, so I have to borrow. Again, a fact that I know, 5 times 10 is going to give me 50. Now, I'm using 10 because I know it's going to get me a product, which is what I'm putting here, that's less than my dividend, or less than what I have remaining. I can't go over this number. I can't go over this number. I can't go over this number. I have to stay below it. But I want to get close, and I want to take big chunks out. Okay, so I'm going to subtract this piece, and I'm going to get 135. I could take 50 away again, and I'm getting even smaller now. Again, I can't subtract 3 from 5, but I'm looking at this whole part here, and that's 13, so 13 minus 5 is 85. Again, I'm going to take 50 more away. And I'm left with 35 this time. Now, I know my fact that's going to get me to 35. I know that 5 times 7 is going to get me 35. Sorry, it's so small there on the bottom, and when I subtract, I'm left with 0. In order for me to figure out what my quotient is, I need to add all these pieces up, or my partial quotients. So 10, 20, 30, 40, 47 is my answer. Now, I could solve this problem a different way as well. Let's say I thought about a different fact to use. Instead of starting with 5 times 10 and getting 50 and taking that piece away, I want to take a bigger piece out of this number. So I'm going to look at this 2 and ask myself, can 5 go into 2 evenly? No, it can't. So instead, I'm going to extend that out and look into my 23. And I'm going to think, can 5 go into 23 evenly? It can't go in evenly, but I'm going to get close. In order for me to get close, I'm thinking about the 5 facts that I know. I know that 5 times 4 gets me 20. That's close to 23. But I need to also remember about my place value. My 2 here is in my hundreds place. And my 3 here is in my tens place, and my 5 is in my ones place. Now, when I'm multiplying, again, I want to take a big chunk out of the number. So if I just multiplied 5 times 4 and got 20, that wouldn't really take a big chunk out of my number. Instead, I'm going to multiply 5 times 40. 5 times 40 is going to give me 200 to subtract. 235 minus 200 gives me only 35 left. Now I think to myself, do I know the fact 5 times what is going to give me 35? I do know that fact. 5 times 7 gives me 35. And again, I subtract, and I'm left with 0. So I know I can stop. Now, all I have to do in order to find my final quotient is to add all my pieces up, or my partial quotients. So 40 plus 7 gives me 47. Let's take a look at a different problem, and we'll solve it again 2 different ways. Okay, we have 9 going into 207. Now, let's say I looked at this 20 here, and I couldn't think about a fact that 9 went into that was close to 20. So instead, I'm just going to start with 9 times 10. Because I know that fact, and I know that 9 times 10 is going to get me 90. 90 is less than 207. So that's a fact that I can start with. 9 times 10 gives me 90. Okay, I'm going to subtract, and I bring that 7 down. I borrow, and I'm left with 1 there and 1 here. Now, I can use 90 again because it's less than 117. So again, I'm going to multiply 9 times 10, and I'm going to get 90, and I'm going to subtract. 11 minus 9 is 2, and I'm left with 27. Now, I can't do 9 times 10 anymore. That's 90. That's too much. I need to think about a fact that comes at 27 or less than 27. So, I have to think about my 9 facts. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. So I'm going to multiply 9 times 3, and I get 27. And again, I'm going to subtract, and I get 0. So I can stop now. In order to find my quotient, again, I have to take all these pieces, add them up, and I'm left with 23. Now, you could solve this problem a different way as well. You could start like this. You could say 9 going into 207. How many times? 207 divided by 9. You could say, if you're looking at this 20, you remember the fact that gets you close to 20 but not over. You know that 9 times 2 gets you 18, and you want a big chunk out of this number, so you're going to multiply 9 times 20. 9 times 20 is 180, and now I'm going to subtract, and when I subtract, I bring that 7 down. I'm going to borrow. 10 minus 8 is 2, and I'm left with 27. Now again, I have to think about my 9 facts. 9 times what gets me 27? Let's say you forget that 9 times 3 is 27, and you go with 9 times 2, because you use that 2 above here, so you know that 9 times 2 is 18, and you subtract. You're left with 9. And then how many times does 9 go into 9? 1 time. Again, regardless of how you solve this problem, when you add up those pieces, you're still left with 23. It doesn't matter how you're getting those partial products, as long as when you add them up, you get the correct quotient. Now, in order for you to check to make sure your quotient is correct, you can always check with multiplication, because remember, division is the opposite of multiplication. So I'm going to take 23 times 9 over here, and I'm going to multiply. 9 times 3 is 27. I put my 7, and I carry my 2. 9 times 2 is 18, plus 2 more is 20. Okay, is that the dividend that I started with? Yes, it is. So 23 is the correct quotient. Okay, we're going to take a look at one last problem and how we can solve this problem 2 different ways again. I'm going to write it out both times this time. All right, let's take a look. Now, I'm going to underline my 29, and I'm going to think to myself, what do I know, what fact do I know about 8 going into 29, or something close? I don't remember any. So I'm going to start with 8 times 10. That's always a starting point as long as my divisor times 10 is less than my dividend, or less than what I'm starting in. With this case, it is. 8 times 10 is 80, so I can start there. I'm starting to chip away at that number to make it smaller and smaller and smaller. 8 minus 0 is 8. 9 minus 8 is 1, and bring that 2 down. Now, that's still less than 80, so I'm going to bring 80 on around again. And I'm going to subtract 80. 8 minus 0 is 8. I have to borrow. And I get 3 and 1. Okay, again, that's still less than 80, so I'm going to bring over my 80 again. And I'm going to subtract. 13 minus 8 is 5. Now, I can't do 80 again because I'm left with 58. So now I have to start thinking about my 8 facts that get me close to 58, but not over. All right, well, I remember that 8 times 8 is 64. 8 times 7 is 56. So I'm going to use that fact. 8 times 7 gets me 56, and I'm going to subtract, and I'm left with 2. Now, here's where I have to stop and think. Here's my divisor. It's 8. Here's what I have left over. It's 2. 8 does not go into 2, so my 2 actually ends up being my remainder. It's what's left over. Now, in order to find my quotient, I'm going to take all of these numbers over here and add them up. 10, 20, 30, 37. And I have a remainder this time. My remainder is 2. That's what's left over. Okay. I'm going to try it a different way because there's another way that I can solve this problem. If I take a look at 298 divided by 8, I can think about my multiplication facts that I know, especially when it comes to 29, and I can think and think and think and say, okay, well, 8 times 3 is 24, so that's where I'm going to start. Again, instead of just 3, because my 2 is in the hundreds place, I have to think 8 times 30 in order to get 240, and be subtracting that. 8 minus 0 is 8, 9 minus 4 is 5, and I'm left with 58. Now, let's say you didn't remember that 8 times 7 was 56, but you did remember that 8 times 5 was 40, because that's a pretty easy fact for us to remember. So that's what I'm going to start with. I'm going to bring my 5 over here, and I'm going to bring 40 over here. 8 times 5 is 40. Okay, I'm going to subtract 18. All right, now I have to think about my 8 facts again. I know that 8 times 1 is 8. 8 times 2 is 16. That's less than 18, so I can subtract that. And again, I'm left with 2. Now, 8 is greater than 2, so 8 does not go into 2 evenly. So this is my remainder. Here are my pieces. I have to add them together, and I'm left with 37, remainder 2. Now, I told you before that you can always check division with multiplication, and you can do that even when you have remainders. So let's take a look. I'm going to multiply 8 times 37. 8 times 7 is 56. I carry my 5. 8 times 3 is 24, plus 5 more is 29. Now, my remainder gets added on to my product at the very end. I have a remainder of 2, so I add that on. And there it is. That is what I started with as my dividend. So I know that my quotient of 37 remainder 2 is correct. All right, guys, I'll see you later.